So today I got to teach you function notation. Function notation. This is equivalent to, you know how there's normal handwriting? You know how there's script? They mean the same thing. One was developed because it was supposed to be faster. You know that's why script handwriting was created. So that you didn't have to take your pencil off the paper, and it was meant to be faster. But, you know, what happened? It became sloppy. Some people understood it, some people didn't. In any event, in math, there's another kind of notation. It's called function notation. It was invented by, I think it was invented by Leibniz, one of the founders of calculus, right? And he invented it so he could keep track of the things he was plugging into equations. And also, if we use function notation, guess what the thing is? It's a, if you see an equation with function notation, like an f of x, and we don't have to use just f, we could use g, h, I, j, k, l, m, n, o, p, q, r, s, t, u, v, w, x, y, z. You could use all of them, right? Even a, b, and c, right? If you see function notation, it's a function. Functions pass this test, the VLT test. Functions pass the vertical line test, which means there's no repeats of the x value. So if you see something written with function notation, by default it gets all those properties. It's like, remember in geometry when we talked about parallelograms? Yeah. So automatically get all those properties. Let's talk about this. Let's talk about how we could say it. If you see something written like this, this means f of x. F of x. It's the same thing as using y. So if you see f of x written down and you don't like doing it because it confuses you, take this thing over here, delete it, and put a y. Let's talk some more. To use f of x, the equation must be a function. That means it's got to pass the vertical line test. Then we got to talk about something else. Do you see this? F parentheses negative 3. You got to put the parentheses. This means it's pronounced f at negative 3. So the function at negative 3. And when you see it, it means sub negative 3 in for x. And here's an example, right? Here's the original equation over here. F of x equals 2x plus 10. Right, we're finding f at 3. F at 3, look what I did. All I did was just plug negative 3 in right there. Simplify it down. And then f at negative 3 equals 4. What does that mean? It means that negative 3 comma 4 is a coordinate on the graph. So negative 3 is x, and 4 is y. You down with this? Okay, all right. Come on, time to go. Flip over your sheet. Flip over. Come on. Flip over your sheets. Flip over your sheet for a minute. We're going to practice a few of these. So here's the examples that are written on your sheet. Let's just go through them. 9. We got f of x equals 7 minus x. Let's plug negative 3 in. So find f at negative 3. So what do? That's just going to be 7 minus negative 3. How much is 7 minus negative 3? Oh, good. Equals 10. And you could leave it like that, right? This also means what coordinate is on that graph. Negative 3, comma 10 is on the graph. Okay? This is an ordered pair. This is called a relation. An ordered pair, an x, y. It's also referred to as a relation. What's up, Carly? You got to be really careful. F doesn't equal anything. Okay? F at negative 3. In other words, the function, this equation right here, Here's the old way you would have written this equation. The old way that you would have written this equation down is like y equals 7 minus x, right? And then what you would have done is you would have done y equals 7 minus negative 3. And then you would have gotten y equals 10. But mathematicians did this. Look what happens in the end. You get y equals 10, right? But you don't remember the beginning parts of the problem. Suppose a problem is like really long. You want to remember what you plugged in or where on the graph you're looking. Then this tells more information than that, and so it's more useful, and it's really not that much more to do. The thing you have to keep straight in your head is you know how we use parentheses for stuff? Like sometimes when items are on the outside of the parentheses, you distribute them in. When we use function notation, don't distribute the f into the negative 3. That would make no damn sense. Should we pick another equation on here? Is this confusing? No. Not at all? Let's pick another equation on here. Let's see what people get. Let's go with something relatively more difficult. Yeah, let's go with 13. Let's go with 13. You know I think this week is Friday the 13th? You were? That explains a lot. Shh. Come on. Come on. Come back. You guys know that we're recording, right? I'm just going to let it run, honestly. Okay. Come on. Come back. So, come on. So let's come back for a minute, right? Here's the equation. Here's the equation it gives you. But then in the directions, it asks for how much f at negative 3 is, right? How do you reconcile the two? John? Yeah, we just changed the y to an f of x, right? Y is the same thing as saying f of x. So it's f of x equals the square root of 1 minus x. And so f at negative 3 equals, for this problem, but not for the rest of your life. Yeah, it says in the directions. Equals, what 1 minus negative 3 is? 4, and what's the square root of 4? So f at negative 3 in this particular case is 2. We get this. I don't think we need to spend a lot more time on it. Yeah? Time to move on? Okay. Now suppose instead of an equation, right, they give you a graph. How do you find stuff? How do you find stuff out? Any ideas? How about Zoe? Nate, take a look, right? You're telling me I just plug that in for what? What's that little 2? What spot does it normally take? What normally goes there? What letter? An X. So what they're trying to say is that 2 is the X. What is the Y value that goes with it? So all you do is look on the graph over at 2 and up over here, and it's going to be what? It's going to be 2. Right? There you go. Now let's play again, because some people could get lost in that. Let's play again, right? Take a look. It tells you, Sean, what letter is normally in that parentheses, X or Y? Yeah. F of X. So negative 5 is taking the spot where there is normally an X. So go over negative 5 units in the X direction, and then find the Y that goes with it. And so it's going to be negative 3. That's how these work. No. It's not bad at all. In fact, this is one of the easier tests that you take in this class. It's just a matter of learning to read what they're doing. I would say next week. Or maybe if I can get through all this week, but I don't think so. I think you're going to have a test like Wednesday. Okay. How about negative 2? Negative 2. What number goes with negative 2? Oh, good. Yeah, negative 2. And then how about when f is 3.5? 3.5 is just 2. Yeah. Okay. Hold on one second. Hold on one second, though. As I'm realizing the way that we've written them down, you understand that this first part is not the answer. It's only the stuff in green that's the answer. You know what I mean? So 2, -3, -2, 2. I apologize. No, it's not that it's wrong. It's just I want you to understand what your answer should look like on a piece of paper. So f at -2, how much was it equal to? F at -5, how much was it equal to? F at -2, how much was it equal to? And f at 3.5, how much was it equal to? What? 2. So that's what ultimately your answers should be. I apologize for the other way it looked. The next problem is probably going to be the worst for all of you because it involves taking a real-world situation, translating it into a math problem, and solving. That's better? The sales tax on a purchase is a function of the amount A of the purchase. The sales tax rate in New York, in the city of Eastchester, is 8%. So, it's 8%. So how would you write a function? Write a rule that describes a function. Tax is a function of the purchase price. You know how we normally do f of x? Tax is a function of the amount A of the purchase. If the sales tax rate in the city of Eastchester is 8%, write a rule in function notation that can be used to determine the sales tax on the purchase in Eastchester. How do we write 8% in terms of terms of a decimal or a fraction? Is it 0.8 or 0.08? So it's going to be 0.08a. That's our function. That's our function. And when we plug things in and out of it, you'll be able to tell A, how much you purchased the something for, and B, the price that was associated, and B, the tax that was associated with it. Let's do B. Let's do B. What's a reasonable domain for this function? What's a reasonable domain? Now, domain refers to the x or to the y values. Remember, domain are the x values. So what's the domain for this particular function? And by reasonable, I mean like if you graph that equation, it would be a straight line. But there's something that won't make sense in real life for this. Where is the domain? Think about what it means. First of all, the domain is represented by what? No. Okay, so let's talk about in this particular case, right? If you graph coordinates right here, okay? If you were to graph coordinates, the x value is really A. It's really purchase price, okay? And the y values for this particular case are going to be sales tax. And this is the domain. And this is the range. Now think about the possible values for the domain, for the domain that makes sense. Are there some values, in other words, that don't make sense? Emily.
Well, since it's a purchase price, anything less than 0.
Exactly. Anything less than 0 is not going to make sense. Yeah, very nice. Way to go. That was hard. I would even go a step further that it almost doesn't even make sense to have 0 in there, just because you can't. Yeah, it's got to cost something. It's got to cost something. So what is the domain? What's the domain that we're looking for? We're looking for A to be greater than 0. That's our domain. Yeah, the purchase price. You could use the parentheses for it. If you didn't want to write it like that, you could have said, oh, let's see, soft bracket on 0 all the way off to infinity. That would have done the same thing. Soft bracket on 0 because it's greater than 0. Yeah? Hold on a sec. Let's do C. Let's do C. Find the sales tax when the purchase price is $5. The purchase price is $5. Can somebody do 0.08 times 5? I mean, I think it's like, think of it. What's up? Yeah. Well, not $4. Yeah, yeah, it'd be 40 cents. It'd be 40 cents. No, 0.08 is 8%, man. Eighth penny, you're a funny guy, man. Okay, let's do the last one. Let's do the last one. Right? Let's do D. Let's do D. I want you to find the sales tax when it's $16.50. That's 0.08 times 1650. There you go. And so if it's $16.50, it's $1.32. So let's talk about the algebra of functions. Let's talk about one other way that you can see a mapping, right? We talked about this, a little bit. Let me show you what this means. This first, circle-looking thing. Is this the domain or the range? It's the domain. This represents the x values. Over here, this is the domain or the range, the second one. The range, it represents the y values. So you could say that this second one is h of x. So if h at -3, how much is h at -3? Equal to? Yeah, it's equal to 11. Very nice, Sean. Very nice. You're the man. How about, what's h at 1? Nah, chill. Yeah, because it moves from 1 to 2. H, the function maps 1 to 2. How much is h at 3? And now here's the tricky part. If h of x is equal to 5, how much was x? Let's trace it back. If h of x is equal to 5, then what was the x value that went to it? Oh, 5. What's up? Ooh. A good call. I missed that one. Or could have been -1. Good call, Brandon. Good call.
People must hear my name who watch videos first.